All right, part 2, number 11 here. It says this one will need to let u equal 4x plus 1, which means du then is equal to 4x to the third. Okay, again, I have, well, dx there. Again, I have everything I need there and there, except for I don't have the 1/4. So we'll put that out in front, 1/4 the integral of u to the third, u to the second. And then the rule says 1/4 the integral, well, now I've done the integration. Oops. Let's do some erasing. And go back to, let's see, now that would mean u to the third power over 3. And we will go from 0 to 1. So I'll just write that as 1 over 12. Like that. Plug u back in. Well, let's not plug u back in. Let me alter these. If I plug 1 into here and in 0, the numbers that I would plug in then would be 1 to the 4th is 1. So that's a 2. And if I plug in a 0, that's a 1. Now I don't have to go back in and plug in the original u. I can just take those numbers. Let's see, we said it was u to the third. And we'll go from 2 to 1. Okay, so if I plug in a 2 into that, 2 to the third is 8. So I have 8. If I plug in a 1, I get 1. So I have 8 minus 1, which is 7, and then times 1 over 12, so it's 7/12. Okay, number 12. Kind of the same thing. Now, I think this one actually comes out to be an odd function. I'm not sure, but I'm going to go through it and we'll kind of see where we're at when we're all done. Let u equal x to the 4th plus 1. Du is equal to 4x to the third. Kind of the same thing. I'm just missing a 1/4. So we'll write this as 1/4 the integral of u to the 4th du. Integrate that 1 over 4 u to the 5th over 5 plus, excuse me, not plus c, and then we'll plug it in from -1 to 1. Alright, so again, I'm not going to actually plug those numbers in. I'm going to plug them into here to see what I get. So if I plug in a 1 in there, I should get 1 plus, or 1 for the 4th plus 1 is 2. And the same thing here, it's 2. Now I realize my interval, I'm going to start at 2 and I'm going to end at 2. So there's no change there. So if you think of it as area, I have no area, so then it's just 0. Okay? Alright, and 13 here, let's look at that. 13 says, looks like I just need to expand. So we will write this as the natural log of x to the third plus natural log of y to the second minus the natural log of z to the 4th, and send all the powers in front. So then I have 3 natural log of x plus 2 natural log of y minus 4 natural log of 2. Excuse me, not 2, z. Sorry, I can't read my own writing. Okay, number 14. I believe the only thing I can do is just send the power in front, so it's 1/2 the natural log of x plus 7. Okay, there's nothing I can really do with that x plus 7. 15 looks like we're condensing. Alright, so I send that back, and that back there, so that becomes the natural log of 9. 3 to the second is 9, and times the square root of x squared plus 1. Right, yeah, 1/2, okay. And number 16, let's see, got a lot of things on bottom, but I do have an x plus 1 on top, all over x times x minus 1, and we have the natural log of that. Okay, I mean, I suppose you could, if you wanted to, you could distribute that through, but I don't think that's necessary. Alright, number 17, the derivative. Alright, natural log derivatives work like this. Keep the original problem on bottom, and divide by put the derivative of the denominator on top. Okay, pretty much that's all I've got. Okay, number 18. Probably help here if we expand this. So let's write this as the natural log of x minus 2 squared minus the natural log of x plus 1. Send the power in front, so I have 2 natural log of x minus 2 minus the natural log of x squared plus 1. So that's a square up there. Alright, so this one should be 2. Derivative of x minus 2 is just 1, so it's 2 times 1 over x minus 2 minus 2x over x squared minus 1, or excuse me, x squared plus 1. Okay, if you want to find a common denominator, you can, but let's see, that would be 2x squared plus 2 minus 2x squared minus 4, or excuse me, plus 4, all over x minus 2 times x squared plus 1. So you could just write it as 6 over x minus 2 times x squared plus 1. Okay. Number 19, send the power in front, 1/2, and then natural log of x minus 5 minus natural log of x plus 3. Okay, now this one I'm not going to bother to expand, or I'm not going to bother to find the common denominator. But I will just say that this is the natural, or it's 1/2, and then times 1 over x minus 5 minus 1 over x plus 3. Okay, I don't have the space here to combine that all, but you can imagine what it would be. This, the x plus 3 would go up over here. The x minus 5 would go over there. You'd change all the signs and then just combine the denominators. Number 20. Let's see. Natural log of cosine. So that means I need the derivative of cosine on top, which is negative sine of x, all over the original. Negative cosine, or negative sine over cosine is just negative tangent of x then. Oops. Okay. All right. Now 21. We get to the derivative, or the integral. So we need to think backwards. You need to make sure that the derivative of the denominator is on top, so x squared minus 1. Well, the derivative of x squared minus 1 is 2x. Okay, I have an x, so I'm missing the 2. So we'll just divide by 1/2. So that's just 1/2 the integral of, the derivative of u over u itself. So that just means I just have 1/2 the natural log of u plus c. So that means my answer is just 1/2 the natural log of x squared plus 1 plus c. 22. Double check that the denominator has the derivative on the top, so 1 plus sine of t. The derivative of that is equal to the cosine of t. Again, I'm all taken care of. I'm perfect here. So that means I can just write my answer basically. It's just the natural log of 1 plus sine of t plus c. Okay, and the last one. If I were you, I would just look this up off the table, but you can do it a little differently. I don't have my book with me, but if I'm going to take a stab at this, I'm going to say that you just look it up off the table. It's the natural log of secant of x plus tangent of x plus c. Probably need a 5 somewhere. 5's there, and probably have to divide by the 5. That one you will want to double check, but it's in the front of your book table. I just don't have my book with me. Okay? Just to reemphasize, the reason why I have to put that 1/5 out in front is I still do have to account for that 5 there. Well, basically I have to make sure, okay, I would have to have the derivative of 5x somewhere. The derivative of 5x is 5. Well, I don't have a 5 anywhere in the problem out in front of secant. And so that's where that 1/5 comes from, is to account for that. And I did double check that. This should be correct. It should be the natural log of the absolute value of secant 5x plus tangent 5x.